Hello good day viewers. In this tutorial I am going to show you why the use of unit cycle as well as the reference angle is very important in solving trigonometric equations. Today we have a very simple equation which is sine of theta equal to -1 divided by 2, and we would like to use unit cycle to find all the possible angles that will satisfy this equation, where this theta represents an angle. So the question is, sine of what angle is equivalent to -1 divided by 2? All right, you can see the output is negative. First of all, what you should know is the position of that angle. So let us start using reference angle first. So if we say reference, we always use angles in the first quadrant because the ratio of all angles in the first quadrant are positive. So if we use the reference angle theta, we can call it another name different from this one. For example, sine of theta bar. I'm using theta bar as a reference angle. So I'm going to take +1/2 because in the first quadrant, everything will be positive. All right. So if it is positive, you should expect sine to be in the first quadrant as well as what? In the second quadrant. But do not forget about our initial equation, which is negative. Our solution must be in the third and the fourth quadrant, because these are the only places where sine function is negative. But it is positive here and here. So if we use the reference angle, assuming that our solution, the output of the equation is positive, definitely we'll get two solutions, one here and the other one here. But our main concern is the reference angle, which is always in the first quadrant. So if you take sine inverse of both sides, you have theta bar to be equal to sine inverse of 1 divided by 2, which is what? 30 degrees. So it means what? In the first quadrant, we have 30 degrees. Let us locate it somewhere here. This is 30 degrees. But what I want to remind you is that our main equation has solution in here and here. So now let us extend this. And also here. What do we need to know? The measure of this angle must be 30 degrees. Likewise, this one must be what? 30 degrees. They will have all the same measure. So coming back to our main equation, which is sine theta equal to -1 divided by 2, where we are expecting our solution to be here and here. Just observe. We use 30 degrees as a reference angle, but this is going to be our solution. Let me use another color for that. This is 0 degrees, right? From the standard position, you are going to count it like this, down here. This is first solution. Then you recount all over again from here, down here. You have two solutions. So what will be the first solution here? You know this is 180 degrees, right? 180 degrees. From the standard position down to this leg is half a cycle, right? That is 180. But we have 30 degrees extra. So to find the first solution here, you're going to add 30 degrees to 180 degrees. Therefore, this particular angle theta is equal to 180 degrees plus our reference angle, which is 30 degrees. And this will give us what? 210 degrees. And this is the first solution. Or theta is equal to, just observe, we have another 30 degrees here. So if you are going counterclockwise from 0 down to 360, you can see that this particular angle is 30 degrees less than 360 degrees. Therefore, to obtain that particular angle, you say 360 degrees minus that other reference angle. And this will give us what? 330 degrees. So we have two values of theta from 0 to 360 degrees that will satisfy this particular equation. And we are not done yet because a condition is not given. Suppose you are told to find the solution from 0 to 360 degrees, you have to stop here. We have two solutions, either 210 or 330. But since there is no condition given to you, you have to find all the solutions. Just observe. This is our first solution. If you start from here, you go round counterclockwise back to this one, you're going to obtain another coterminal angle. We call them coterminal angles. They do not have the same major, but they have the same ratio. For example, if I should take 0 degrees, and I go round back to this point, I will have 360 degrees. Therefore, 0 and 360 degrees have different major, but have the same ratio. If you take sine of 0 and sine of 360, you're going to get the same output, the same result. So keep on adding 360 degrees, you will be getting more and more coterminal angles, more and more solutions. So you add 360 degrees multiplied by k, for which k stands for 0, 1, 2, 3. It could be -1, -2. So k is just an integer. If k is 0, you have only 210 as your solution. If k is 1, you have 1 times 360 plus this, you're going to get another solution. K equal to 2, 3, 4, it could be negative or positive. The same thing here, you add 360 degrees k, right? For which k is an integer. So this is how to obtain the general solution. But had it been our original equation was just equal to 1/2, your solution will be here and here. So the second solution here will be less than 180. Therefore, you have to take away 30 from 180, which is going to give you 150. So it will be 30 and 150 in the first and the second quadrant. But because our output is negative, the solutions must be in the third and the fourth quadrant. So this is how to use unit circle as well as the reference angle to find the solution to this particular problem. But the question is, what if you are not allowed to use unit circle? Let me show you. Let me show you how to do that. From here, first thing to do is to locate the position. We definitely know that they are going to be here and here. So you take sine inverse of both sides directly. Theta will be sine inverse of 1/2 negative. And sine inverse of this will give you negative 30 degrees. Because it is going to count it clockwise. And once you count angles clockwise, they will be negative. Instead of 30, it will be negative 30. But to make it positive, smallest positive angle, you can add 360 degrees. Right? You can add 360 degrees if you like. Adding 360 degrees here, it means that you are moving backward from the standard position. No, from that particular point back to where you started. That is the coterminal points. And this will give you what? 330 degrees. You see one of the solutions? And what you should know is that sine of negative 30 will give you negative 1/2, as well as sine of 330 degrees. But this is just one solution. If you want to obtain the two solutions, let me show you how you can do that. Remember what I told you about these two solutions. If this is 30 degrees, this will be 180 minus 30 degrees for you to get this other solution. There are two, which is 150. So from the starting point, you can see that sine of that 180 degrees minus the angle, because you have to subtract the angle from 180, it will still be negative 1/2. So by taking sine, you have two equations now. By taking sine inverse of each of this equation, the first one will be theta equal to negative 30 degrees. And this is 180 minus theta will still be negative 30 degrees. If you take sine inverse of negative 1/2, the output will be the same, negative 30. Then you take this to the other side, you bring this one. Taking negative theta to the other side, it becomes positive. And this is negative. Once you bring it in, it becomes positive. We have 180 degrees plus 30. And this will give us what? 210. Can you see that? So we have one solution here and the other one here. Though this one is negative, and I told you if you want it positive, you can add 360 degrees to it, and it will become the smallest positive angle, which is 330. They are all the same. Negative 30 or 330 degrees. They are all the same. So these are the solutions from 0 to 360 degrees. But as always, I told you, if you want to get all the solutions, you can add multiples of this 360 degrees, such that the solution will be what? Theta equal to 330 degrees plus multiples of 360 degrees, which is a complete cycle. Or the other solution will be 210 degrees plus multiples of this 360 degrees. Because the moment you start from that point, you go around, you come back to where you started, though the ratio, the measurement will change, but the ratio will remain the same. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.